Okay, Justin, good morning. Or whatever it is when you are watching this. I'm going to touch on four things from the stuff that your mom sent me. The first one is mixed fractions. Uh, this is something you're going to find, especially as you hit algebra, that mixed fractions are going away. You're not going to be talking about 3 and 5/8 much longer. But instead, you're going to look at what the improper fraction is. In this case, we go 8 times 3 is 24, plus 5 is 29/8. You're going to see that this is the preferred version, and we're going to get away from this. 3 and 5/8, you know the picture. You've seen the circles, and you have, here's 3, there's 8/8, there's 16/8, there's 24/8, and then 5 more would give us 29/8, or 3 and 5/8. So that's the picture, but trust me, you're not going to see these much longer. But what you are going to see all the rest of your life is finding the common denominator. And let's go ahead and stick with the mixed fractions for now. Let's suppose that I'm adding 3 and 5/8, and I'm adding to 2 and 4/5. My first step, of course, is to convert these into improper fractions. This is going to be 29/8 like before. This one is going to be 5 times 2 is 10, plus 4 is 14/5. And my problem is I have two different denominators. I have an 8 here, and I have a 5 here. And I need to make these into a common denominator. Here's what I do. First of all, I think, well, let's see, 8, that's 2 times 2 times 2. 5 over here is a 5. If I multiply these prime numbers together, I'm going to get my least common denominator. 2 times 2 times 2 times 5 is 40, is my least common denominator. So I'm going to ask myself, what do I need to multiply 8 by to get 40? Well, the answer is that 5. So I'm going to multiply it times 5, but as your mom and dad can tell you very quickly, if you do it on the bottom, you have to do it on the top. Same over here. What do I need to multiply 5 by to get 40? Well, I need an 8. So I'm going to do it. But of course, if I do it on the bottom, have to do it on the top. Now I'm ready to do some business. 29 times, I'm going to multiply 29 times 5 and 14 times 8. 29 times 5 is 29 times 5, 45, carry the 4, 5 times 2 is 10, plus 4 is 14, that'd be 145. I can check that by saying, well, 29 is close to 30. 30 times 5 is 150, so it makes sense that I'm 1/5 less than that. So it's going to be 145. And then over here, 14 times 8. 8 times 4 is 32. 8 times 1 plus 3 is 100, or is 11, so that's 112. I can check that by saying, well, let's see, 14 is close to 15. 15 times 8 is going to be 80, plus 40 is going to be 120, minus an 8 is going to be 112. Those are quick ways you can you can do these kinds of things, and practicing doing this sort of thing in your head is great to do. And then, of course, my denominator is that 40. So now I'm ready to add these up, and I have 145 plus 112 is 257. I'm just in my head saying 1 plus 1 is 2, 4 plus 1 is 5, 5 plus 2 is 7, and I get that over 40. Now, at this point, if you wanted to write this as a mixed fraction, you could. That would be 6 and 17/40ths if you wanted to, do that. But I'll tell you this, in algebra, in pre-calculus, in calculus, however far you go, that's your answer. That's what you want. Don't mess with mixed fractions much anymore. Now I wanted to talk real quick about triangles. Your book talks about triangles, and it talks about obtuse triangles and acute triangles, and it has all kinds of names and things to memorize. The best mathematics is not done by memorization. The best mathematics is done by thinking. And I want to say that your book says that all triangles have 180 degrees when you add the three angles. That is, this angle plus this angle plus this angle all add up to 180 degrees. Well, a good mathematician will read something like that and he'll say, prove it. You make this statement, it sounds good, but is it true? Is it right? Well, I'm going to do that for you. I'm going to draw this line, and this line is parallel to this line. So I have this line and this line. Now off to the side, from geometry, if you have two parallel lines and a line going crossways through there, there is I can't remember if it's an axiom or a theorem. I think it's an axiom that this angle and this angle are the same. It is called the I can't remember the name of it. See, I don't do math very well as far as memorizing names and titles. I do math by thinking, and I just know that this is true, that when you have this transverse line, that those angles are, your dad's probably laughing at me right now. Okay, anyway, because of that, this angle, and I'm going to indicate it by 2 bars, is equal to this angle. These are my parallel lines, and here's my transverse line. Now I'll do this one with 3 bars. It's going to equal this one. And so now, can you see that this angle plus this angle plus this angle is indeed 180 degrees. So your book will often do that, and it will say things like that, and it will be a little short perhaps on the proofs, because it seems that math books these days tend to do that. But I want to let you know that this really is true. Triangles have 180 degrees, and you can draw any triangle you want, draw this parallel line, and show it. Last thing I want to talk about is the circumference of a circle. I'm going to draw this cross. I'm going to draw a circle. I always get a little short on that one. Okay. The circumference is, let's suppose you had an acre of land and you had this circle of a fence, and you started at this end. You were walking that fence line and you walked all the way around and you got back to your starting point. You would have done the circumference of the circle. The interesting thing about the circumference is, for a long time people have tried and successfully done, they've related the radius of the circle, that's the radius going from the center out to the edge of the circle. They have tried to, and they've come up with a number, but it's a number that has an infinite number of decimal places after it. But they will take that radius and they'll stretch it along this fence line. There's one radius. There's two radiuses. There's three radiuses. Doesn't quite make it to this one here. It gets a little short. Then 4, 5, 6, of course, still doesn't quite make it there. We need a little bit more. This 6.28, however many digits there are. I know that the halfway point is, when you get to this point right here, is 3.141592654, and that's an approximation. I think it goes 390 or something like that. Anyway, this thing that goes on and on and on to this halfway point here, we give the Greek letter, I'm sorry, I'm going to mess it up because you're thinking he's going to say P. But I'm sorry, mathematicians call it pi. So 6.28, that is 2 pi. You're going to have to argue it out with your folks, whether you say P or pi. But at any rate, that's where that comes from. It's from taking that radius and stretching it around this circle. So when you are figuring that if you have a radius of, say, 5, the circumference of the circle is equal to 2 times pi times 5, which is 10 times pi, which is 31.414, etc. And always when you're talking a problem like this, you're going to be rounding off. Justin, it's been a great first class. Hope you get it. If you're stuck on something, send me a text. Talk to you later.